Hello and welcome to Investment Insight. Before we begin, make sure to subscribe and hit the like button. Now let's break down what's happening in the markets today in a clear and simple way. So whenever you hear about the massive AI boom we are living through right now, almost everyone focuses on the chips themselves.
Oh, absolutely. It's all about the chips.
Right. The intricate designs, the raw processing power, the relentless race to make transistors smaller and faster. But according to recent analysis, there is a massive, hidden traffic jam in how those chips are actually put together.
Yeah, the assembly part.
Exactly. And that specific bottleneck, well, it could be the key to one of the biggest corporate turnarounds in U.S. history.
It really is the untold story of the AI revolution, honestly. Because the mission for today's deep dive is to examine whether Intel can actually step up and break TSMC's absolute grip on the AI packaging market. We are going to look at the underlying technology, the heavy geopolitical push happening right now under the current Trump administration, and, crucially, what the hard financial data actually means for you, an everyday investor who's just trying to separate the hype from the reality.
Okay, so let's unpack this hidden traffic jam first.
Okay.
Because to understand the financial opportunity Intel is staring at, you really have to understand the physical, real-world problem the AI industry is running into right now.
Right, the physics of it.
Yeah. For decades, the hardest part was just printing the microscopic circuits onto the silicon. That was the magic trick.
It was. Making the die was everything.
But now we are moving into a world where making the individual chip is only, half the battle. Actually assembling multiple chips together into a final product is the real nightmare.
Oh, it's incredibly difficult.
I like to think about it like the automotive industry. So imagine the tech world is busy building the most advanced, powerful, 1,000-horsepower car engines ever conceived.
Okay, I like this.
Right. But suddenly production just grinds to a halt. And why? Because there is a massive global shortage of the specific chassis, the specialized mounting brackets, and the cooling systems needed to actually install those engines into a working car.
Yeah, and the engine is totally useless if you can't mount it.
Exactly. You just have a really expensive paperweight.
That's actually a highly accurate way to look at it, because right now, TSMC, that's the Taiwan Semiconductor Manufacturing Company, they are the undisputed king of building that chassis for high-end AI chips.
Right, they own the market.
They do. They use a dominant packaging technology called CoWoS, which stands for chip-on-wafer on substrate. Now, CoWoS is incredibly powerful, especially for the absolute top-tier graphics processing units, or GPUs, that companies like NVIDIA make.
The ones powering all the big AI models.
Exactly. But here's the catch. CoWoS relies on something called a silicon interposer.
Okay, yeah, I've seen that term in the industry reports. What exactly is a silicon interposer, in plain English?
Sure. Think of the interposer as a giant, incredibly expensive foundation plate. Because modern AI chips aren't just one piece of silicon anymore.
They aren't.
No, they're made up of a central logic die, basically the actual brain doing the math, and several memory dies, which act like the brain's filing cabinets.
Ah, okay. Brain and filing cabinets.
Right. And to process AI quickly, the brain and the filing cabinets need to talk to each other at lightning speed. So TSMC takes all these separate pieces and places them side by side on top of this giant silicon foundation, the interposer, which has microscopic wires built into it to connect everything.
Wait, so instead of making one big chip, they are taking several smaller chips and essentially gluing them down to an even bigger piece of silicon just to connect them.
That is exactly what they're doing.
That sounds incredibly complex to manufacture without, messing up.
Oh, it is. And that is precisely where the traffic jam happens. First off, it's just phenomenally expensive to manufacture a piece of perfect silicon that large.
I can imagine.
If there is even a microscopic speck of dust on that massive foundation, the whole thing is ruined.
Wow.
Second, it creates a massive supply bottleneck, because only a few highly specialized facilities in the entire world can make these giant interposers.
So everyone is just waiting in line.
Exactly. But the third issue is the most fascinating from a physics perspective. These AI chips run incredibly hot, they draw massive amounts of power.
Right. I mean, anyone who has ever rested a working laptop on their knees knows that processors generate serious heat.
Yes, exactly. Now, multiply that laptop heat by 1,000.
Oh, wow.
And when materials heat up, what do? They expand. but different materials expand at different rates. Because you're bonding all these different components to one massive silicon foundation, the uneven heat distribution actually causes the entire package to warp and bend.
Wait, it literally bends.
It does. And if it warps even a fraction of a millimeter, those delicate microscopic connections snap, and you just destroyed a $30,000 AI chip.
That is wild to think about. So the biggest tech companies in the world are bottlenecked because their cutting-edge chips are literally bending from the heat.
Yep, that's the reality of it.
So, okay, if TSMC's massive foundation approach is causing this global traffic jam, how exactly is Intel proposing to bypass it?
Well, Intel's alternative is a technology called EMIB, which stands for Embedded Multi-Die Interconnect Bridge. Their philosophy is completely different.
How so?
Instead of building one giant expensive silicon foundation underneath everything, EMIB embeds tiny, isolated silicon bridges directly into the packaging material, but only exactly where two chips actually need to connect and talk to each other.
Okay. Let's bring this back to an everyday example for you listening.
Mm-hmm.
Imagine urban planning, right? TSMC's approach is like paving an entire massive multi-acre concrete plaza just so people can walk between two specific office buildings.
Right, a massive concrete slab.
Exactly. It works, but it's expensive and takes forever to build. Intel's EMB approach is like saying, well, why pave the whole city? Let's just build a small targeted footbridge exactly where the doors of the two buildings meet.
I really like that analogy. And according to recent data, that targeted footbridge approach significantly simplifies the structural complexity.
Because there's less material.
Exactly. Because you aren't using one massive rigid piece of silicon, you drastically lower the mechanical stress. The whole package has more flexibility, meaning you lower the risk of it warping under high heat.
That makes a lot of sense.
Now, to be totally objective, based on current analysis, EMIB might not perfectly replace CoWoS for the absolute highest end ultra-low latency GPUs just yet.
Okay, so TSMC is still top dog for the absolute best stuff.
Yeah, TSMC still holds the crown for ultimate performance. But for custom AI chips, where companies want to balance cost, decent performance, and supply chain stability, EMIB is becoming a highly attractive alternative.
Which naturally brings up a crucial question. Who actually wants these custom chips?
A lot of people, actually.
Right, so if Intel's EIB is perfect for custom AI processors, we have to talk about the hyperscalers. For those who might be new to the term, hyperscalers are the massive tech giants. Google, Meta, Microsoft, Amazon, the ones who operate cloud data centers at a global scale.
The biggest buyers in the world.
Exactly. And right now, they're desperately trying to build their own custom hardware.
They absolutely are. And to understand why, we really need to look at the economics of what they are buying.
Let me try an analogy here. Let's think about dining out. For a long time, all these tech giants have been buying general-purpose NVIDIA GPUs. And NVIDIA chips are incredible. They are like the ultimate Swiss Army knife.
Best in the business.
Right. They can handle generating images, writing text, complex math, literally anything. But it's like going to an incredibly expensive, crowded five-star restaurant every night.
Yeah, the line is out the door.
Exactly. And if you are Google and your AI is going to do one very specific type of search algorithm 1 trillion times a day, using a Swiss Army knife is inefficient. You don't need the corkscrew and the scissors. You just need a highly specialized scalpel.
It's a great way to put it.
So these companies are tired of the restaurant, and they are starting to hire their own private chefs to make exactly what they want at home. They are designing their own custom chips, known as ASICs, or application-specific integrated circuits. They are hardwired to do exactly one job perfectly.
That is the exact shift we are seeing in the market. The hyperscalers are saying, look, we can design the scalpel ourselves to save power and money, but we still need a manufacturer to actually package it.
Someone has to actually build the physical thing.
Right. And we are seeing incredibly strong industry signals pointing toward Intel to do that packaging. Based on recent reports, Google is heavily rumored to be adopting Intel's EMB technology for its next-generation TPU V8.
And a TPU is their custom chip,
Right. Yeah, tensor processing unit.
Yeah.
Designed specifically for Google's AI workloads, and they are targeting late 2027 for this. Meta is also reportedly reviewing EMIB for their MTIA custom AI chips.
But wait, I have to ask. If Google and Meta are essentially throwing their massive weight behind Intel's solution, how do we know this isn't just, industry gossip? What does the hard data actually tell us right now? We have to look at the balance sheet.
Good point, because if we look at Intel's Q1 2026 earnings, the data actually starts to back up this shift. Intel's data center and AI revenue, Their DCAI division hit $5.1 billion.
Wow, 5.1 billion.
Yeah, that is up 22% year over year. And even more telling for this specific topic, their custom ASIC revenue jumped over 30% sequentially.
So they are clearly making money on the custom stuff.
Definitely. And here is a critical detail for investors to watch. Intel's CFO, Dave Zinsner, recently adjusted their 2026 capital expenditures.
Capital expenditures, meaning the money they are spending to build factories and buy equipment.
Correct. Originally, Intel was projecting a decrease in that spending, but Zinsner revised it to remain flat year over year.
Oh, interesting.
Yeah, and when asked why, he specifically stated it was to support confirmed demand and customer backlog in their advanced packaging division.
I see, because you don't keep the corporate checkbook open to that degree unless the orders are actually materializing.
Exactly. You don't build the factory if no one is buying the product.
So they are actively spending money to prepare for these custom chip orders. But where is all this happening? Because one of the big selling points for these hyperscalers is moving away from the geopolitical risks of having everything assembled in one place, like Taiwan.
Right. Supply chain security is huge right now. So Intel is aggressively building a global blueprint to avoid relying on a single region. The research and development leadership, the real cutting-edge engineering, is anchored in the U.S., specifically in Oregon.
Keep the IP at home.
Exactly. Then they have a massive multi-year expansion underway in Malaysia. That facility is specifically targeting that 2027 confirmed revenue demand we just mentioned for companies like Google.
Got it. Oregon designs it, Malaysia builds it at scale.
Right. Furthermore, they're growing operations in Vietnam. Just recently, on May 8, 2026, Intel had a high-level meeting with the Vietnamese Science Ministry to expand their tech ecosystem there.
So they are really spurting out.
They are. And we even have supply chain data showing that Taiwanese equipment makers are already receiving significant orders from Intel for machinery to be delivered in late 2026.
Okay, so it's a highly coordinated, multinational supply chain. They invent it in Oregon, they get the machines from Taiwan, and they do the mass assembly in Malaysia and Vietnam. It's designed to be a massive release valve for the TSMC traffic jam.
That's the perfect way to summarize it.
But it's not just the enterprise data center looking for alternatives, is it? This push to use Intel is extending to the consumer side, to the most valuable consumer brand on the planet, and it comes with some incredibly heavy geopolitical backing.
Yes, I know exactly what you're about to bring up.
I'm talking about the massive May 8th report from Reuters and the Wall Street Journal indicating that Intel and Apple have reached a preliminary agreement for chip manufacturing.
Yeah, that was the headline that really shook the market when it dropped.
I have to push back here, though. Let's be real. Imagine you are Tim Cook, you run Apple, a company famous for being, obsessed with perfection and incredibly tight control over its supply chain.
Oh, entirely.
Are we really supposed to believe that Apple is going to hand over the production of its flagship iPhone chips to Intel tomorrow? Given Intel's struggles over the past few years, that seems like an absurd leap of faith.
It would be a massive leap, which is exactly why we have to temper expectations here. Neither company has officially commented on the specifics of this preliminary agreement.
Right.
And if we analyze the historical data of how Apple manages its supply chains, it is highly, highly unlikely that Intel will be making the Core A-series chips for the main iPhone anytime soon. TSMC still has that lockdown tight.
So what's the actual play here? If Intel isn't making the main iPhone brain, what are they doing for Apple?
It is much more realistic that this partnership starts with low-volume, lower-risk components. We are talking about coprocessors, maybe legacy chips for older iPads, or specialized controllers.
So they are just testing the waters.
Exactly. The true value of this preliminary agreement isn't about immediate, massive revenue for Intel. It is about the restoration of trust. It is about Apple actively taking steps to test Intel's capabilities and secure a viable backup supply chain located within the United States.
Which brings us to the political context, which is really the unseen hand driving a lot of this momentum.
Yes, you absolutely have to talk about the current landscape in Washington because you cannot decouple economics from geopolitics right now.
Right. So under the current Trump administration, there is an intense top-down strategic push to rebuild domestic semiconductor champions.
Right, bringing manufacturing back to the U.S.
The government views the current reliance on overseas manufacturing, specifically in East Asia, as a critical national security vulnerability. To counter this, Commerce Secretary Howard Lutnick has reportedly been in repeated direct contact with major tech CEOs.
Yes, he's been very active.
The reports state he has made calls to Tim Cook at Apple, Elon Musk, Jensen Huang at NVIDIA, actively encouraging them and, well, perhaps applying some political pressure to collaborate with Intel and help build out this domestic manufacturing base. We are just looking at what the reports are saying here, to be clear.
Right, the administration's goals are very explicitly stated in the policy documents.
It's a fascinating convergence. You have the technological need for an alternative to TSMC perfectly overlapping with the political desire from the White House to bring manufacturing back home.
It sounds like a guaranteed home run for Intel on paper.
It does. But as an economics show, we have to bring this back to reality. We have to look at what Intel's actual business looks like today, not just the rosy projections for 2027.
Yes, let's look at the actual numbers.
So let's use a real estate analogy. Imagine you are an investor looking at a massive, newly renovated hotel.
Okay.
The lobby is absolutely gorgeous. The local government is out front cutting the ribbon. VIP guests are making reservations for next year. But if you walk upstairs today, right now, the rooms are entirely empty.
Not a single guest.
Right. There are no paying guests, and the hotel is burning a massive amount of cash just to keep the lights on and the staff paid.
That is the sober reality check every investor needs to hear. Because the Q1 2026 financials for Intel's foundry business, the division responsible for making and packaging these chips, are undeniably tough.
How tough are we talking?
Well, they reported $5.4 billion in total foundry revenue.
Okay, that sounds like a lot of money.
It sounds great until you look under the hood and realize a staggering majority of that revenue is internal. It's simply Intel making standard computer chips for Intel's own PC division.
Oh, so they are just paying themselves, essentially.
Basically, yes.
So what was the actual number for external customers? The hyperscalers and tech giants they are trying to win over.
External foundry revenue was merely $174 million for the quarter.
Wait, wow. $174 million out of $5.4 billion.
Yeah, it's a drop in the bucket. And it gets tougher. Overall, the foundry division posted a $2.4 billion operating loss for the quarter.
So they lost over $2 billion in 3 months.
Yes.
That is a stark, jarring contrast to all the exciting headlines about Apple agreements and Google TPUs. So for the everyday investor listening to this, how should they be viewing this company? If the future looks bright, but the present is hemorrhaging cash, what's the play?
Based on the analysis, you should not view Intel as a guaranteed turnaround story just yet. The most accurate financial framework is to view Intel stock right now as a packaging call option.
Okay, let's break down that term for our beginner economics listeners.
Right.
What is a call option in this context?
Sure. So in traditional finance, a call option gives you the right to buy a stock or an asset at a specific price in the future. You pay a small fee, called a premium, today for that potential future upside.
Okay.
If the stock goes up, your option is super valuable. If it doesn't, you just lose the premium.
Yeah.
Right now, investors buying Intel are essentially paying a premium based purely on future validation.
So they aren't buying it for what it's doing today.
Exactly. They aren't buying the company because of that tiny $174 million in external revenue today. They are buying the stock as a bet, an option, that the late 2026 equipment deliveries in Taiwan and the 2027 factory expansions in Malaysia will actually translate this current backlog of interest into real, profitable external revenue.
I see. You are buying the option that the empty hotel actually fills up with paying guests next year.
Precisely. That's exactly it.
A packaging call option. I really like that framing. It acknowledges the massive potential without ignoring the current cash burn. It's a bet on execution.
Execution is everything here.
And if we look even further down the road, past the 2027 Malaysia expansion, there is another technological leap on the horizon that could make that call option incredibly valuable. Let's talk about 2028 and the shift to glass.
Ah, yes. Glass substrates. This is the next true frontier in semiconductor packaging.
What makes it so revolutionary?
Well, we talked earlier about how traditional organic materials and giant silicon interposers warp under heat, right?
Right, the bending and the microscopic wires snapping.
Well, AI packages are only getting larger, and they are consuming significantly more power. We are talking about chips that draw 1,000 watts of power individually. That generates exponentially more heat. And if the foundation warps, the chip is ruined.
Right, so we established that heat is the enemy of the current foundations. So why glass? It seems counterintuitive to put delicate electronics on something we associate with being, well, fragile, like a window breaking.
I get that a lot. But it's not the kind of glass in your living room window. This is highly engineered, specialized glass. And it solves several problems simultaneously. First, glass is inherently flatter and much more mechanically rigid at high temperatures compared to organic materials.
So it won't bend.
Exactly. It handles thermal expansion beautifully. It simply does not warp the way current materials do. Second, glass has incredible signal integrity.
What does signal integrity mean for the actual performance of the AI?
It means data travels faster and cleaner. Current organic materials actually absorb some of the high-frequency electrical signals as they pass through.
Like friction.
Yeah, essentially. But glass doesn't. Because the signal stays pure, you can pack the microscopic wiring much, much closer together. If Intel can successfully commercialize the combination of their targeted EMIB bridges embedded in these new ultra-flat glass substrates, the entire dynamic of the industry changes.
They wouldn't just be viewed as a backup alternative to TSMC's CoWoS anymore.
Exactly. They wouldn't be the backup.
Oh.
They could actively dictate the fundamental blueprint for the next generation of AI packaging. They would hold the patent on the best chassis in the world.
Is massive.
It is. But, just like the Apple deal, we have to stress that this is a long-term play. Working with glass requires entirely new supply chains, brand new laser inspection tools, and completely new manufacturing processes.
Right.
It is not going to impact the balance sheet tomorrow.
Right. Okay, so let's synthesize all of this. We have a massive physical bottleneck in the global AI supply chain because TSMC's giant silicon foundations are incredibly hard to make and prone to heat damage.
Right.
The hyperscalers like Google and Meta are looking for a way out because they want to build custom, highly efficient AI scalpels, not general-purpose Swiss Army knives. Intel has the EMIB technology to offer a targeted bypass, and they're aggressively building out a multinational footprint in Oregon, Malaysia, and Vietnam to scale it up. And to top it off, they are getting a massive geopolitical tailwind from the current administration to secure domestic supply chains, leading to preliminary talks with titans like Apple.
That is the complete macroeconomic picture, perfectly summarized.
But as we discussed, the financial reality is that they are still burning billions to build this infrastructure, and external revenue is currently a drop in the bucket.
Yeah, that $174 million is a tough pill to swallow.
It really is. It is a high-stakes call option for investors who are willing to wait for the Malaysian factories to come online and for the glass substrate future to become a reality. Execution over the next 18 to 24 months is going to be absolutely everything.
Make or break.
Which leaves you, the listener, with a really fascinating question to chew on. Think about how we view the tech landscape. We have spent decades defining semiconductor companies by one metric: how incredibly small they can print a transistor on a piece of silicon. Right, the nanometer race.
Exactly. The smaller the transistor, the more valuable the company.
Yeah.
But if the real bottleneck, the true physical choke point of the entire AI revolution, has actually moved to how we package and assemble these pieces, could the future Intel be wildly successful, not as a traditional chip maker, but instead as the world's most advanced, highly specialized assembly and logistics hub for other companies' designs? It completely flips our understanding of what makes a tech company valuable in the AI era.
It's a completely new paradigm.
It really is. Don't forget to subscribe and hit that like button.